in deep neural networks, we apply convolution, two-dimensional convolution at convolution layers. So here, if we are considering 3 by 3 window as shown here. So this particular is pixel under consideration, and say we are applying averaging mask where all the weight values are 1 and entire sum is scaled by 9, or we can say all the weight values are 1 by 9. So we can apply a filter with all weight values as 1 by 9. And so we apply this two-dimensional convolution, and this is your resultant value, right? So with this convolution technique, we also talked about relation between output image size and input image size. So this output image size depends on various parameters like what is input image width, what is filter size, whether you are using padding, if yes, how many layers of padding you are using, and what is the stride rate. Okay, so this is the equation to determine output size. So output size W2 is given by W1 minus filter size plus 2 times padding whole divided by S. So this is stride whole divided by S plus 1. This gives you resultant image width. Okay, so in general, so in addition to these parameters, one more parameter is depth of the input. So if you have a color image, input image depth is 3. There are 3 planes corresponding to, one corresponds to red, then second corresponds to green, and third corresponds to blue. So this depth also decides the depth of the output. Okay, so output depth is same as input depth. So this relation between input and output and filter size. So once again consider this. So W1, H1 and D1 be the width, height and depth of input image. Let S be the stride. Let K be the number of filters. Let F be the size of the filter and P be the padding. Okay, so according to, if all these are the inputs and say W2, H2 and D2 be the width, height and depth of output image after convolution, then the relation between these output parameters and input parameter is given by these equations. W2 is determined by W1 minus F plus 2P divided by S plus 1. H2, that is height of the resultant image or output image, is given by H1 minus F plus 2P divided by S plus 1, and depth at the output is same as depth at the input. Okay, so let us consider one example. Say there are total 96 convolution filters, stride rate is 4, and input image size is 227 by 227 by 3. And if filter size F is 11 by 11 and no padding is used, means P is equal to 0. Then in order to determine this width, we can use this equation. W2 is equal to W1 minus F plus 2P divided by S plus 1. So in this equation, W1 is 227. Then filter size is 11. So it is 227 minus 11. Stride is 4, so it is divided by 4. As P is 0, there is no third term is 0. So we get only these values, 227 minus 11 plus 0, whole divided by 4 plus 1, this results in 55. Okay, so similar to W2, we will get height H2 because here W1 is same as H1. W1, H1, both of them are 227. Similarly, filter length, width and height is same, it is 11. So your H2 value is same as W2, so H2 will be 55. And depth is 3 for the input, so hence it is same for the output. So resultant output image will be 55 into 55 into 3. And there are such 96 filters. So total output size will be 96 multiplied by 55 multiplied by 55 into 3. So this is resultant output size after applying this particular convolution layer. Okay. So the same is shown here as an image. So 227 by 227 by 3, this is your input. We are applying a filter of size 11 by 11 into 3 because we are applying this filter 11 by 11 for all the 3 layers. So this is the resultant output 55 by 55 and there are 96 such filters and this every 55 by 55 is further multiplied by 3 to represent the 3 layers in the input image. Okay. Is this clear how we get the output size from one particular convolution layer? Is it clear to all? If it is clear, then we can proceed for next example of convolution layer. Please type yes or no, or if you have any doubt, please type your question, or you can unmute and ask. Kindly let me know whether this size calculation at the output of convolution layer, is it clear to you? Okay. So thank you, Netra. So hope it is clear to all, or if you have any query, you can ask me. Okay. So in CNN, every layer, convolution layer is followed by pooling layer or polling layer. So here we have seen in the basic diagram that there are convolution layers. Every convolution layer is followed by polling layer. So this is convolution layer. This is polling layer. Again, there can be next convolution layer. Again, polling layer. Okay. So this what is meaning of the polling layer? So this polling layer aim is to reduce size of the data. So basically it generates subsampled image. So polling layer basically performs subsampling. Okay. So we can use different types of poolings. Either we can use average pooling, minimum pooling, or maximum pooling. So let us see what is meaning of this pooling. So this is your input image. And for pooling layer, here we are considering stride of 2. And the filter size used is 2 by 2. So we consider this 2 by 2 filter size. Okay. And here let us see how to apply max pooling. So max pooling means from the selected neighborhood, we select maximum value. So in this neighborhood, their values are 3, 4, 6, and 5. So maximum value is 6. So here we get value as 6. Okay. Then stride is 2. So we shift this mask by 2 columns. So next position of mask is as shown here. Okay. So again we check which is the maximum value. What is the maximum value in this window? 7893. So maximum value is 9. So we replace this pixel by 9. Then again, as the stride is 2, we shift this mask downwards by 2 rows. So the next mask position is as shown here. Again, we determine the maximum value out of these 4 values. So maximum value is 12. So we replace this position by value 12. Then again we shift the mask by 2 columns. So this is next mask position. So again here we determine maximum value. Okay. So here maximum is 11. So we get the value 11. Okay. So this is how we can apply pooling mask or pooling layer. Now instead of maximum, if we use minimum mask, tell me what will be the resultant value. So now we are using minimum mask. mean pooling with stride 2. What is the resultant value? Yes, Sharan, very good. So whenever we are using minimum filter, again we start with very first 2 by 2 window, because filter size we are considering it's 2 by 2. So here your resultant output size will resultant output will be 3, because we are considering minimum. So here we will get value 3. Then because of stride 2, this will be next area or window. Again here minimum value is 3, so here we get output as 3. Then next window is this one. Here minimum value is 2, so we get here value 2. And then next area window is this, and minimum value is 3, so we get here 3. So this is minimum pooling. So instead of max pooling and minimum pooling, we can also use average pooling. So in case of average pooling, we consider average value of the pixels. So 3 plus 4, that is 7. 7 plus 6, that is 13. 13 plus 5 is 18. 18 divided by 4. So it will be 4.5. So it will be average to value 5. Okay. So in case of averaging, we consider average of all the pixels under the given window. Okay. So in case of max pooling with filter size 2 by 2 and stride 2, here whatever your resultant image size will be half of the original image. If we consider stride as 2, and if your filter size is 2 by 2, then resultant size, image size will be half of the original. So in this example, your input image size is 4 by 4 and resultant image size will be 2 by 2. So this is a type of subsampling, right? Okay. So this is so ultimate reason of using pooling is to reduce the image size and to reduce number of computations and storage requirement for further layers. Okay. So filter, what we can use can be of any size, and higher the size of the filter, lesser the output size. Okay. So for next layers, we need less number of parameters. Okay. So is this concept of pooling layer is clear to you? So pooling layer is not used to extract the features, but it is simply used to reduce the size of the image and hence the number of parameters for the next layers in your convolution neural network. Okay. Is it clear to you? Concept of pooling? Is it clear to you all? If you have any doubt, please ask. Okay, I am getting few yes answers. Okay, so hope this is clear to you. Okay, Vedika, thank you. Sharan, thank you. Okay. So this is, we just now consider what is the result of minimum pooling. Okay, then what will be the output if stride is 1? In this example, can you determine the result of result with stride 1? Result of pooling layer with filter size 2 by 2 and stride 1. Okay, so consider max pooling with stride 1. Max pooling with stride 1. So as in case of previous example, first we apply the filter, here we determine the max, we get the value 6. Now as the stride is 1, we are scrolling this mask only by one column. So now we are considering this particular window where the pixel values are 4, 7, 5 and 9. So here when we apply max operation, here we get again 9 as max value. Then we need to scroll it once again here. Okay. So very good, Vedika, you have answered it correctly. So at third position, here we will get one more output because the stride is 1. We get the third area and we determine maximum for this window. So here again we get 9. Now on similar line, determine next all values when we apply max pooling with stride 1. So your next position will be this. So again maximum value is 12. Now continue this process. So now we are applying it here. Here maximum value is 12. So you will get value here. And once again, we scroll it only by one column. So here we will have next element. So what is the resultant value at this position? Can anybody answer? Abhiraj, Akshat, Amog, what is the resultant value? Anurag, Manik. Yes, Rajanandini, it is correct. Here you will get 11. Okay, Sharan, you have asked query to repeat it. See here, stride parameter decides by how many columns or how many rows we are scrolling the mask. So we have started with mask position, initial mask position. Then we shift it only by one column. Okay, so we shift it here. After we apply the pooling here, then we shift it once again by one column. So it will be here. Once we complete all the columns, we shift it downwards by one row. So next position will be this. Again, we shift it by one column and so on. Is it clear, Sharan? So it is similar to your convolution operation, but the aim of stride is aim of pooling layer is to reduce the image size. So stride of 1 is rarely used in case of pooling layer. Usually stride value is same as your filter width. So as we are here considering filter of size 2 by 2, stride used is usually 2. Okay. But here if we use stride 1, what is the resultant image size? Resultant image size will be 3 by 3. And what is result for this last row? Can anybody type? Vedika has already answered. Anyone else? So for last row, very first position, here we will get maximum value as 12. Okay. Max pooling we are applying. Then for next position, again 12 is maximum. And for third position, 11 is maximum. So this will be result. Hope this is clear to all of you. But mainly for polling layer, aim is to reduce image size. So the greater stride rate is used, and usually it is same as the filter size. Okay. So if the stride is 1, we will get this output. Now let us talk more about convolution neural networks with one particular type of network which is already available as so this LeNet is an example of convolutional neural network. LeNet 5 is basically used to recognize handwritten characters. Okay. So it is used for application of handwritten character recognition. So as shown here, for this network, input image is used of size 32 by 32 and it is a gray image. So depth is 1. Okay, so depth of the input data is 1 and width and height are same, which is 32. Okay. Then there is Very first layer is convolution layer. Now, as shown here, total 6 filters are used, and each filter size is 5 by 5. Okay, so for very first convolution layer, filter size used is 5 by 5 and stride rate is 1. Okay, now with this given data, please tell me what is the resultant image size. Your input image size is 32 by 32. Filter size is 5 by 5 and stride rate is 1. Okay. So what will be the resultant image size? So for that, you can use this equation W2 is equal to W1 minus F plus 2P divided by S plus 1. Now here, padding size is not mentioned, means padding is not used. Whenever P is not mentioned, it indicates that padding is not used. Okay. So P is 0, W1 is 32, filter size F is 5, and stride used is 1. Then what is the resultant size? So Chaitanya, can you answer this question? Manik, Netra, Zishan, Rutvik, Vedasri, Vaishnavi, Gauri, try to answer this question. So for after completion of these two convolution layers and subsampling layers, there are fully connected layers. So here your image is 2-dimensional. We need to convert it to 1 dimension. So it will become 16 into 5 into 5. So total there will be 400 nodes. 400 nodes are to be connected to all these 120 nodes. So we need weights which are equal to 400 into 120. And for every node from this layer, we need a bias term. So we are adding 120 here. And thus 400 multiplied by 120 is 480,000 and plus 120. So this gives us total number of weights between this flattened layer and C5 layer are 48120. Now for next layer, 120 into 84, that will be total number. All these 120 nodes are to be connected to these 84 nodes. So for next layer, we need 120 into 80 plus for every node we need here a bias term. So there will be 84 bias terms. So in all we need 10164 weights between C5 and F6. Is it clear? And now at the last layer there are 10 nodes, and so determine number of weights between F6 and output layer. In output layer there are 10 nodes, and for layer F6 there are 84 nodes. So please type your answer in the chat box. How many trainable weights are there for the output layer? So it will be simply 84 into 10, 840 plus 10 bias term, that is 850. So for last layer, that is between F6 and output layer, we need 84 into 10 plus 10, that is 850 nodes, 850 weights, trainable parameters. Okay. So for this LeanNet 5, how many are the total trainable parameters? We need trainable parameters for convolution layer C1, We also need trainable parameters for convolution layer C3, which we have already calculated. And we need trainable parameters for all the fully connected layers, that is C5, F6 and output. Okay. So for fully connected layer, so weight between S4 and C5 are, we have already calculated, these are 48120. Then number of weights between C5 and F6 are given by this 120 into 84 plus 84. So these are 10164. Then between F6 and output layer, we have 84 into 10 plus 10, that is 50 nodes. So add all these weights to get weights for fully connected layers. Similarly, for convolution layer C1, we need 156 weights. For C3, we need 2416 as trainable weights. So we need to add all these weights to determine total number of trainable parameters. So total trainable parameters for fully connected layers plus total trainable parameters for convolution layer, that will give you total for the entire LeNet5 network. So total 1 and plus total 2 gives you the total number of parameters. So just verify it. So it is 61,706. Okay, so huge amount of trainable parameters are required. So this number is huge in spite of we are using convolution operation. So here we are using window operation, and again same weights are used for the entire image. So if we consider feature filter say F1 of size 3 by 3, all those weights, 9 weights are used for the entire image. So in spite of applying sharing, in spite of applying windowing concept, we need huge amount of trainable parameters for convolution neural networks. So usually in order to implement convolution neural networks, we use parallel computation platform, so that by using parallelism, we can compute the output of applying a filter for an entire image in only one cycle. All all filters can be applied on the entire image parallelly, so that you can reduce the amount of computation. Okay. So I hope this concept of convolution neural network is clear to you. Now, can anybody answer why this is known as LeNet5? Why not LeNet8, LeNet10 or LeNet1? Why the name is given as LeNet5? Can anybody guess from this diagram why it is known as LeNet5? 5 layers. See, total number of layers is more than 5. 1, 2, 3, 4, 5, 6, 7. There are total 7 layers. Filter size is 5. No. That can be one of the reasons. Yes, Sharon, we can say this is very logical, because for all convolution layers, filter size used is 5. But one more reason is there. Actually, there are 5 trainable layers. This convolution layer, say C1, is trained during training process, means though all those filter coefficients are trained. Similarly, layer C3, all the filters in layer C3 are trained during training process, and these are the 3 fully connected layers which are trained. So total there are 5 trainable layers: C1, C3, C5, F6 and output layer. So as there are 5 layers which are learnable, yes, Jishan, you have answered it correctly. Okay, so for this reason, this LeNet is known as LeNet5. Okay. So like you have LeanIt 5 for character recognition. Similarly, you can have LeanIt 5 to perform some object detection operation as shown here. You can have LeanIt example. Again, here there is one convolution layer, then pooling layer. Again, you have one convolution layer, then pooling layer, and there are few fully connected layers. Okay. And here activation function used is softmax. For last layer or for output layer, activation function is used is softmax, and for intermediate layers, activation function used is value. So we will talk more on this softmax activation function in next lecture. So that's all for today's lecture. I request you all to type your attendance in the chat box and then leave the meeting. Thank you all. Now, once again, I like to tell you about your group activity. So on next Wednesday, we will have presentation by 3 groups, group 1, group 2, and group 3. So start preparing the literature survey. If you have any query related to survey, you can contact me at any time. And on coming Wednesday, we will have presentation by group 1, 2, and 3. And on Thursday, we will have presentation by next 3 groups, that is group 4, group 5, and group 6. Okay, so hope you have finalized with the topic. If you have any doubt regarding the survey or topic, you can contact me. Don't hesitate to contact me. So today at 1:30, we will have practical session. Okay, thank you all.